Hi, I am Khugaanraj and my matrix number is 08DNP22F1007. I'm here today to give an explanation about the rate of change to you. Before starting with our presentation, does anybody have an idea about what is rate of change? Okay, never mind, let me give my answer to you about that. The rate of change of a quantity refers to how that quantity changes over time. Typically, the rate of change is given as a derivative with respect to time and is equal to the slope of a function at a given point. The rate of change of a function varies along a curve and is found by taking the first derivative of the function. The derivative dy dx or dy over dx of a function y times x is the rate of change of that function at the point x, y. To make it more simple to understand, rate of change is a process of finding a rate which a quantity changes by relating the quantity to other quantities. The rate is usually with respect to time and the symbol of time is t. Okay, now let us move to the example or question. A block of ice in the form of cube its side x cm melts at the rate of 9.72 cm cube per minute. Find the rate of change of x at the instant when x equals to 12 cm. We have mentioned that the ice is in the form of cube, and for cube the volume is same for every side, which is height, width and length. And the side are given as x cm, so we'll put x in the height, width and length. From there we can get the volume of the cube, which is x cubed. When differentiating, we will get 3x squared for dv dx. Moreover, they have mentioned that the melting rate of the ice is 9.72 cm per minute, and we can get dv dt, which is 9.72 cm. Since the ice is melting, we put negative in front of 9.72 and it will become as negative 9.72. To get the rate of change, which is dx dt, we should times dx dv with dv dt. By that we can get dx dt or the rate of change. Since we have dv dx, it's easy to get dx dv by changing it to 1 over 3x squared. We can get dx dv. So we have dx dv right now and dv dt. And we can start to times dx dv with dv dt. So we'll write as 1 over 3x squared times with negative 9.72, and we will write as negative 9.72 over 3 times 12 square. We get the 12 from the x because they have mentioned that the x is equals to 12 cm. So we'll substitute the 12 into the 3. So we'll write as negative 9.72 over 3 times 12 square. And we will get the answer for dx dt, which is negative 0.0225.
Rates of change. Find the rate at which the volume of a spherical balloon is increasing. If the surface area is increasing at the rate of 6 cm square per second, when the radius of the spherical balloon is 5 cm. And here is the balloons, and given the rate of balloon is 6 centimeters square per second, and the radius is given 5 centimeters. And here is the solution to find rate of change of the balloon. And dv over dt, that is to find rates of change, and we still don't know, that we have to find them. And dA over dt, we already got it, that is increase rate 6 centimeters square per second, and r radius is 5 cm given. And here is the formula for spherical balloon, that is v volume equal 4 over 3 pi r cube. dv over dr equal 4 over 3 times 3 pi r 3 minus 1. And we cancel 3 and cancel 3, and all we left is dv dr equal 4 pi r square. And we got this A area equal 4 pi r square. dA over dr equal 4 times 2 pi r2 minus 1. dA over dr equal 8 pi r, that is we solved earlier. dV dt equal dV dr times dr over dt. That is formula we have to find. And that is dA over dt equal dA over dr times dr over dt. dr over dt equal dA over dt, and divided by dA over dr. dr over dt equal dA over dt times dr over dA. And all we do this is change rule. And we got is 6. That is 6 we got from, yes, increase rate and time 1 over 8 pi r. That is we get earlier, this one. Yeah. And result we got is equal 6 over 8 pi r. dV over dt equal 4 pi r square times 6 8 pi r, and we solve it, and we cancel it, and dV over dt equal 6r, that is left, and there is cancel 4 and 8, we got 2 equals 6 times 5. Where do we get 5? So 5 is radius that given, and we divided it by 2, and dV over dt equal to t per 2 over 2 equal 50 centimeters cube per seconds, and that is the rate of change that we get. Thank you.
In mathematics, particularly in calculus, a stationary point of a differentiable function, one of the variable is a point on the graph of the function where the function derivative is 0. Informally, it is point where the function stops increasing or decreasing.
Find the coordinates of the stationary points on the curve y equal x cubed plus 3x squared minus 9x minus 4. So we differentiate it first. dy dx equal 3x squared plus 6x minus 9. At stationary points, dy dx equals 0. 3x squared plus 6x minus 9. After that, we divide the equation by 3. So x squared plus 2x minus 3 equals 0. Then we factorize it and put it in bracket. X plus 3, x minus 1. So x plus 3 equals 0 or x minus 1 equals 0. Therefore, x equal minus 3 or x equal 1. When x equal to negative 3, y equal bracket negative 3 cube plus 3 bracket negative 3 square minus 9 bracket negative 3 minus 4 equal to 23. When x equal 1, y equal negative 9, stationary points at negative 3, 23 and 1, negative 9. So this is the graph. This is the second example of how to find stationary point. Find the coordinate of any stationary point along the curve defined as y equals to 2x cubed plus 3x squared minus 12x minus 1. So first we differentiate it first. So dy dx equals to 6x squared plus 6x minus 12. After that we solve dy dx equal to 0. 6x squared minus 6x minus 12 equals to 0. X squared plus x equals to minus 2 equals to 0. We put it in the bracket. X plus 2, x minus 1. X plus 2 equals to 0 or x minus 1 equals to 0. Next, we find y coordinates. X equals to negative 2. So y in bracket negative 2 cube plus 3 in bracket negative 2 square minus 12 in bracket negative 2 minus 1. After that we get 2 in bracket negative 8 plus 3 in bracket 4 minus in bracket negative 24 minus 1. So we get negative 16 plus 12 plus 24 minus 1. So the answer is y equals to 19. We put it in the bracket negative 2, 19. After that we find the x coordinate. X equals to 1, y equals to 2 in bracket 1 cube plus 3 in bracket 1 square minus 12 in bracket 1 minus 1. Then we get 2 plus 3 minus 12 minus 1. So the answer will be negative 8. So this is the graph that we get.
What did we get from our discussion earlier is we get to know a rate of change and stationary points. That is, rate of change refer to how fast a function's output changes with respect to changes in its inputs. The rates of change can be positive, negative, or zero, indicating whether the function is increasing, decreasing, or neither. For the stationary points, can the other hands are points on the functions where the rate of change is zero. These points can be local maximums, local minimums, or inflection points. The conclusion that we get is rates of change and stationary points are important concepts in differentiations. They are used to describe the behavior of functions. By analyzing these concepts, we can gain a deeper understanding of the underlying structure of mathematics models and their real-world applications. Thank you.